Hello everyone. So in this video, we're going to cover dictionaries. We're going to look at how dictionaries are similar to the lists that we've looked at before, and then explore the syntax for working with dictionaries in Python. We'll also talk a little bit about how dictionaries work under the hood, and when we should use them compared to our other collection types. So with that said, let's go ahead and get started. So we've already learned about lists. We said lists were great when there's an entire group of data that we want to put in just one single variable. Lists were ordered. The elements went in a first, second, third slot, and each of those was identified with a number. This made them great when we were trying to modify an entire group because we could just use a for loop and loop over that first, second, third slot numerically. However, this isn't always the way that a group of information works. Sometimes, when we want to collect related things into one place, we care more about looking something up rather than iterating over the entire group. A great example of this is a literal physical dictionary. With a dictionary, I've got many pieces of information that belong together, definitions of words. But very rarely will I read a dictionary cover to cover. Instead, I like to look up a word by its name and then find out what the meaning of that word is right afterward. That's the value that I'm looking to get out of this dictionary. So this dictionary data type we've got works sort of the same way. If we just had a list of words and their meanings, I would have to loop over every single item one at a time until I found a match. However, with a dictionary, I'm actually going to store two pieces of information that I connect together. There's the value, in our case, the definition of the word, and then there's some key, which is some unique identifier I can use to go and find that value and retrieve it. And that's going to be the big idea of dictionaries, is combining together these values that we worked with previously, but now adding in an accessor that isn't just some numeric index. So let's take a look at how that looks in actual programming languages. So in most scripting languages like Python or JavaScript or anything sufficiently friendly to a user, dictionaries are often first declared just using a set of curly braces. So I've got a variable name and then an equal sign, and then Python will know it is a dictionary because I put a curly brace instead of a square bracket like we did for a list. And then inside of this brace, we do things a little bit differently because I need to associate two pieces of information together. Each item in my dictionary is going to have a key, which is often, but not always, a string, and then a colon, and then a value that is connected to that key. So in this example here, I've got a count of votes for different items we might have for dinner. Say I'm collecting all of my friends, figuring out where we want to go out to eat for some big party, and I start with this dinner votes count, and every time someone gives me their vote saying, oh, I want sushi or I want pizza, I might go and add one to that vote. So this is a group of information. All of the different things people want for dinner are obviously related, but it wouldn't be valuable for me to just put numbers in a list. If I just had 6, 4, 2, 12, I would have a pretty difficult time remembering, well, was the third one the tacos or was it the sushi? Similarly, I could make a list of all the things people wanted, sushi and pizza and tacos and curry, just 4 strings in a list. But then I wouldn't have any information about which one was most popular. So this dictionary allows us to capture both of those pieces side by side and connect them together, saying this particular item has this many votes, or this word in the dictionary has this meaning. We're not just storing a group of things, we're actually storing pairs of associations between two different groups of things. And that's how our dictionary is going to function. Everything revolves around leveraging that connection between the keys and the values. Once I have my dictionary declared, the way that I use it is actually very, very similar to a list. If I wanted to modify my dictionary, I'm going to put the name of a dictionary, square brackets, and then the key. So with our dinner votes here, our keys were all of these strings that were the labels we wanted for the different foods. So inside the square brackets, I can put one of those foods, just like how in a list we could put a numeric index. Only this time, the thing that we've put in has a little bit more meaning. If I look at this and say, oh, the dinner votes for pizza, I get a much better idea of what that would be than dinner votes square brackets 2. So that shows us how these dictionaries can be helpful to us just in terms of readability when we are working with our code. It gives us the ability to very clearly associate some human readable identifier or otherwise recognizable thing in each one of these slots for our data. But otherwise, it works just like a list. I can retrieve, I can modify by just putting that key in the square brackets. And then the programming language will replace that entire phrase, that entire expression, with whatever is the value associated with that key. So that's how our dictionaries are going to work in code, is usually you put the two together with a colon between them. What I want to talk about now is a little bit about how dictionaries actually work, because this looks a little bit like magic, that I can just put the name of this thing and it gives me a number. The way that this actually works is just a slightly clever way to use the lists that we've looked at before. So our dictionaries, even though they appear as a completely separate type, in reality, all a dictionary is a very, very, very long list. It's a massive list with 100 or 1,000 times the slots that you'll ever expect to fill up. And then, any time that we access something or modify something in our dictionary, what your programming language will do is figure out which slot is associated with that particular key. So in our example with these dinner votes, I've got a really big array. I've got this list that has dozens and dozens and dozens of items in it, but most of them are empty. And if you say, well, I want the dinner votes for sushi, then what is going to happen is this key that I've put in is first going to have a special math function applied to it. Something that knows how to uniquely take that phrase that I've put in, or whatever type my key is, and convert it into a number between 0 and however many slots my secret little interior list has. And it's gonna, almost like a roulette wheel, spin round and around and around and land on some number. So say, for sushi here, it lands on the number 3. Then we'll know, because it landed on the number 3, if someone puts dinner votes of sushi, what they're actually looking for is this third slot in this really big list. And so it will do that replacement and go access this slot with that number. And there's a lot of nuance to how that math function is built. It's what's called a hash function. And it's a whole topic. It's weeks and weeks to learn how to write one of these. But the really good news is we can make use of dictionaries just with the understanding that there is such a thing in place. This gives us one really important consequence of dictionaries, though. Remember, we had said one of the big motivations was if I wanted to find something in a list, I would need to loop over each thing in that list one at a time. Say for each item in the list, if it's this one, then I found it. Next loop, is it the second one? Next loop, is it the third one? We would have to check 100 things if there were 100 things in our list. With a dictionary, if you know the thing you're looking for and have an identifier for it, we do that little bit of math and immediately know which spot that thing is in, which means no matter how many different items people have voted for, if I get the exact same name for something, it will always take me exactly one step to find it. I do the math, get the slot, and then retrieve the item immediately without having to search. So that is the huge benefit of dictionaries, is that they allow us to do that. But there is a little bit of a trade-off here. If we look, this list is going to take a lot more room than a list that just has just barely enough space for the things people actually voted for. There's also a lot of nuance in how we handle collisions when two things end up in the same spot, or how we actually use keys, design keys for our dictionary that are reliable ways to find something, because it might be that a key ends up not being unique, or it ends up being a piece of information we don't have when we go to do the lookup. And if that happens, then we end up having to loop over a much, much larger list, which is even slower than if we had just used a plain old regular list in the first place. So it is something that you have to be careful with, but dictionaries are a very powerful tool for doing any type of tagged data collection or collection of data that comes in pairs where there's a key and a value. So just to drive this home, I want to compare dictionaries and lists and talk a little bit about when we want to use each. So dictionaries are going to be really good when we are primarily accessing single items and we have a unique identifier, something that we know we can use to look up. Whether it's that word and its definition, whether it's a item name and its popularity, or a grocery and its price, you need to know there is something I'm using to do the looking up, and there's something I'm using to get the value. And you can't even switch the two. You can't say, well, find me all the groceries that are $2.99. Dictionaries won't be able to help you with that unless you've ordered your dictionary where $2.99 is the key and you're assuming there's only one with that price. So that is when we use dictionaries. On the other hand, if we plan to loop over everything, say we're going to add all these numbers together, like you've got grades in a grade book and they're all pretty interchangeable, that might be evidence that a list is a better fit. Similarly, if we have order, if there's a ranking system, lists put things in an order. With a dictionary, the only order is whatever key you've gotten, whatever random place that key translates to with our mathematical function. So dictionaries are not good if you were storing the winners of a race. You had a sprint and there's a first place, a second place, a third place. A list is going to be a better choice for that type of data. In terms of when we use them, dictionaries end up being more time efficient. It's faster to get that one matching thing when they're used correctly, when we have a good identifier for them. But as we discussed before, lists are a little bit more space efficient. They don't take up as much running memory in your program because we only are allocating just the exact amount of space we need. The last big difference between the two is going to be that dictionaries are great when that index we're using to look something up, our unique identifier, is a string or it's some other type of information that wouldn't be easy to translate into a number for us as humans. but is something that the computer can very easily, uniquely assign some number through that hash function. Lists, on the other hand, only have numeric indices. So if you ever see a variable and then square brackets and a number, hopefully that is a list. It might be a dictionary. You can do a dictionary with a numeric key. But generally, if those numbers aren't very far apart, that's going to be a hint that this is a list. On the other hand, if you see a variable and then square brackets and quotes in someone's name, that is 100% certainly a dictionary, because lists only let you use numbers ever. So those are some of the differences between dictionaries and lists, but there are still similarities, rules that are universal no matter which type of collection you're working with. So the first big point of this is that both of these collection types are able to store a lot of information in one single variable. And this is very valuable whether you're working with a dictionary or a list, in particular when you're combining these tools with a function, because you might have a function and that function might need to figure out who is the winner for the dinner choices that we have, that voting that we were doing. It would be a big pain to have to pass in each item as a separate argument to our function. But with a dictionary, we can just pass in one single variable that has all of the dinner votes. And this is also true of lists. Even if we found a way to store them all in a list, we would only have to pass in that one single thing. Same thing with a return of a function. Whether we're working with dictionaries or lists, both of these are a really great tool to send back more than one thing from a function if you have a whole group of results to return to a user. The other thing is that both of these tools work best when the values are all of the same type. We talked about this with our lists already in the previous video, where if I'm looping, if each slot of my list is a different type, what is my loop going to do? The same thing is true of our dictionaries. If each of my keys is a very different type, then it's going to be difficult to know how to write the code when I don't have the key, because the key is itself in a variable, or it's come from a user, or it's come from something I've calculated through running the program. So both dictionaries and lists are going to work best when the values are all the same type of object, whether that is a number, whether that is text, whether that is itself a list. Just as we saw lists of lists, you can have dictionaries where the values are lists. It's a very neat trick when you do have to store more than one thing in the same key. But no matter what you choose for that value side, it should be consistent for the entirety of your collection. But that shows us that there are similarities to be had between these collections. They are not quite so dissimilar as they would first seem. That is our introduction to dictionaries. We talked a little bit about how to use dictionaries in our code, how to access them, how to assign them new values using that square bracket syntax with a key. We talked a little bit about how they work, how that key gets translated into a number in a very large list, and compared the two of these. So hopefully that gives you enough information to get started practicing with dictionaries, thinking about when it would be good to use them and when lists are actually a more efficient tool. From here, we are going to talk about a more homogeneous grouping of data. We'll be looking at objects and how they compare to these dictionaries. So look forward to that, and I will catch you all in the next video.